All right, much better test here of the electronics as far as the power wiring. Notice you are not seeing any blue smoke. That is very good. Notice you're also not seeing an expensive board going on to this test. So let me walk through what we've got. Hopefully those LEDs aren't too blinding. Okay, what we've got here are my Dakota Lithium batteries. 12 volt, 10 amp hours. They are in the battery box cradle designed by Charlton. I'll link to his video where he talks about that in the description. I've got the batteries wired in series, so I have negative from this battery going to a bus bar. I have positive of this battery looping to negative of this battery. Then the positive of this battery goes to the 40 amp breaker switch. That in turn comes out to this bus bar. So this bus bar is now 24 volt, theoretically. This meter shows, it's a bit shiny because there's a protective plastic I haven't taken off on top of it. It shows 26.8. Again, I have not put my multimeter on any of this yet. I just turned this on. So this multimeter might not be totally accurate, but it is going to be close. The reason is when you have the 12 volt batteries charged all the way, which I just did for the first time yesterday, they read more than 12 volts each. I think it was around 13 and a half when I put my multimeter on each one, which would be almost 27, so this is fairly accurate, 26.8 with a full charge on the batteries. So that is hooked up to this 24 volt bus bar and this ground that the battery is also connected to. So again, in series, negative to a ground, positive to negative of the other battery, positive to the breaker switch to a bus bar. So anything that I connect to this will get 24 volts. Currently the only thing connected is a meter, which is fairly accurate, and this empty fuse block. The power is going into the fuse block. I have a fuse in there, but I didn't attach anything that uses 24 volts. The only thing that I have that uses the fused 24 volts, will be two things. One will be the amplifier, and the other one will be 24 volts that I will send up to the dome, where a smaller converter will convert it to 5 volts to power the things in the dome. But again, this is to check all the wiring is working. So after I put the phone down, I will put a multimeter between these two points, which would be the fused 5 volt 24 volt line and this ground, and make sure that it should measure the same 26.8. Maybe a tiny bit less because resistance of the wire and the fuse block, but it should be pretty darn close to 26.8, measuring between this screw where the fuse is and that ground. Next we have our voltage converter. This is the one that I blew up last time by hooking the wires up backwards. Red wire goes to 24 or 12 volts. This can work off 12 volts or 24. So the red wire is going to the 24 volt bus. Ground goes to the same one that the battery does. Then it has 5 volts out and a ground out. Before I turned anything on, I put my multimeter on this bus bar and this bus bar to make sure they have continuity. Because inside here, even though this ground is coming off the bus bar from the battery and going to this bus bar, the grounds are internally connected. So these two ground strips, bus bars, have continuity, which is what you want. We can see on our meter here, again, I haven't put my multimeter on it yet, but this is showing 5.03, which I really like. If that's anywhere accurate, I prefer that to, say, 5.1, which is getting a little bit high for some sensitive electronics that really like to have a steady 5. So I'm liking that reading if it's accurate, which hopefully it will be. Like I said, this one is pretty accurate. In fact, you can see it went down a tenth while I've been talking there. Okay, so this meter is hooked up to, again, this is our converter that takes 24 and sends it to 5. So this fuse block is getting 5 volts in, and then anything we connect needs to go to a ground. It can go to here, it can go to here, because these two, remember, have continuity. So it doesn't matter which one, but because this one is closest, that's the one that I hooked it to. So I hooked the meter up to one of these screw terminals, which means it needs a fuse. Without a fuse, the meter doesn't light up, which, because I forgot to put a fuse in there when I first turned it on, that one wasn't working. And I had to think, why is that not working? It's because I hooked it up to a fused terminal where I should have hooked it up to this terminal. Because this is where your 5 volt comes in. It's always hot. It's not fused. That's where this meter should be hooked up to, so you don't have one of your 4 areas that are fused taken up with this little meter. So, just for testing again, and learning as I go. I knew that that wasn't going to burn anything out, but now I've learned, oh yeah, if I want the meter to show me the voltage and I don't want to use one of the 4 terminal blocks, yeah, hook it up to where the 5 volts coming in. So yeah, and then there's our second bus bar, and then for testing, and I know it's going to be extremely bright. In fact, yeah, there we go. A little bit less. That is a LED chase light circuit I got for another project. It was only a couple bucks off eBay, and those lights are supposed to be going around in a circle, and they don't. I don't see anything wrong with my soldering, but it's only a couple $1 circuit board, and I've just kind of given up on it. But I knew that at least, in fact, last time I powered it on with a wall wart power supply, all but I think 3 LEDs came on. Now they're all on, but again, they're supposed to be going around in a pattern, and they're not. They're just all lit. But the basic thing I'm trying to say is this was a couple $1 board that I bought off eBay for another project that runs on 5 volts. This is not a $200 board that took me forever to get from Germany. That was a really dumb thing for me to do, to connect that expensive board when I was testing in that last video. Learned my lesson there. Don't do that. The only reason that I wanted to plug something in, 2 reasons. I'm not sure if the meter would be accurate or if it was working after my meltdown, because that is one of the meters that was hooked up. What I did shouldn't have ruined a meter, because it was still going to get enough voltage to be within range. It just wasn't getting 5 volts the way I screwed it up. But it does also show me that once I hooked the one of these that I plugged in during my catastrophe, once I fixed the wiring and I tried powering it on again, it was showing nearly 7 volts up here, so I know I've toasted this. So the one that I used before this is no good, and the switch breaker is no good, and the $200 board is no good. So learn my lesson there. Oh, and the tool battery is no good. So yeah, it's about $250 mistake. Dealing with arcade power supplies, my other hobby, video arcade games, pinball machines. Arcade games sometimes use a switching power supply. Switching power supply takes wall plug power in and creates usually 5 volts, -5 volts, and 12 volts out. And a lot of the switching power supplies tell you that you should not run it without a load on the 5-volt line. So that's why I wanted to hook something up other than this meter on the 5-volt line, because I'm not sure if it's the same for these. I don't know if this would be hurt by having nothing drawing power from its output, or if it would be perfectly fine. I'm not sure. So I figured that is not going to draw enough current to make any difference. That's using just tiny bits of current, I'm sure. So I knew this thing at least came on with multiple LEDs, so I knew it was going to be drawing a little bit of current. So it would be a good board to test, and if I fried it, I don't care because it doesn't work right anyway. So there we go. Like I said, my next step will be multimeter to see how accurate these two meters are by putting positive and negative leads on these two bus bars and see if it matches that, and putting a positive and negative lead on the fuse block here and that bus bar to see if that meter is accurate, and then turning everything off so I can look at see how to make the adjustments. I see it's a metal pot on the back, which usually you don't want to use a metal screwdriver to adjust a metal pot when it's turned on, but I don't have a small tiny plastic screwdriver to make the adjustment, so I'm not sure if it's okay to use a metal screwdriver while it's powered on the back of those to adjust them or not, but I'll look into that before I do it, obviously. But yeah, as far as a second test of the power system, first test of the actual power system that's going into the droid, these proper batteries instead of the tool battery, and after hooking everything up right, I am calling this a successful test of the basic power system and wiring theory. Yep, that's it. Alright, a little addendum to that video that I'm tacking here on the end. This is a data port logic set and charge bay indicator set that I got from Printed Droid Shop in 2021. There's 3 wires that connect these two together, and I decided as a test, now that I know I've got my voltages right, by the way, 5.03 is what the 5-volt measured between the bus bar and the fuse block, so that one was dead on. This one here meters that is measuring 26.6. I put my multimeter on the 24-volt bus and this ground bus, and I got 26.7. So I went into the back of this meter, and it's not even a screw terminal. It's just a little tiny round metal potentiometer, and it had a couple notches in it, so I very carefully put my fingernail against one of the notches and turned it while it was powered off, and then powered it back on, and it read 26.6. My multimeter read I think it was 26.1. So it's within a tenth easily. It's like within 0.09 of being completely accurate on there. So both of them are less than a tenth variance from what my multimeter showed, so I'm happy with the output. Anyway, back to this. So when I plugged these in together and into 5 volts, they're coming off the 5 volt rail here through a 5 amp fuse, these vertical bars were not working properly. They got the two, you can see these are all surface mount LEDs, and the first 2 on this side were blinking, and just exhibiting weird behavior where they were blinking in different colors, and then none of the rest of that row was lighting up, and the other row wasn't working right either. So I pushed my finger down and they start working. And I take my finger off and they mess up again. Just the first two light and they're blinking on and off. They're not steady. So I knew something was probably screwed up with the surface mount LEDs. One of the first three probably. So these surface mount LEDs have 4 pads, 2 on each side where they're soldered to the PCB. So I got the multimeter and I see where they're marked negative, and so I toned out the negative to make sure that they had continuity, and they did. And then I moved to the inside and I was trying to check continuity on the inside, and I noticed when I put my multimeter on that second LED from the bottom, it wiggled. So I determined that, looking at it under magnification, that the 2 inside pads were not making good contact with the PCB. They were not soldered properly. Now, looking at the gap in between the 2 rows, I could see that there were some rework done, it looked like. So after it was soldered by the, I'm assuming, surface mount soldering machine or whatever device was used to do the surface mount soldering, some of them might have had an issue and someone went back and touched a couple of them up. Well, the second from the bottom on that right hand side was definitely screwed up. Both pads were not making contact on the inside. So here is surface mount soldering in a really tight space when I do not have a hot air rework station. But because of my issues of trying to get in contact with Ben Reese about my Astrocomms board and the delay in shipping, the last thing I wanted to do was try and get in touch with him again and say, hey, yeah, I bought this board, 2 years ago and just now plugged it in and it's got an issue. And then who knows how long it would take for him to reply to me, and who knows what the reply would be. And yeah, I just didn't want to go that route. So I decided, what the heck? I am going to touch up the solder, attempt to, on that second LED from the bottom. And, I don't know how good this phone is going to focus on that, but you might be able to see there's 2 little tiny dots of solder on that LED on the inside. So use some liquid flux, put my tiniest soldering iron tip on, and it looks like I've got it. It's working. Before it would not, unless I pushed my finger on it, it would not work properly. It would just, those 2 LEDs would just kind of be blinking, and some of the others would come on sometimes, and sometimes they wouldn't. So just wanted to add that on there. I am not going to buy any more from Printed Droid Shop. Other people have had success. My experience so far has been not good. Communication, I don't think, is acceptable. This board, now, I mean, you could say I've had it, in a box for a couple years. Something could have jostled that one LED. I'd have to disagree, because looking at it under magnification, it was clearly not making a solder connection with the board. There was a gap there. It did not get soldered properly. So that was not knocked loose from movement. That was not properly soldered in the first place. So you can get the same type board from astromech.net. There's in the for sale pages, there's what they call a continuous run of these, where they're basically, if you want to buy one, you just contact the guy who makes them, and he'll arrange it all, the shipping and the payment and all that stuff. I would suggest, just my personal opinion, going that route. The other thing I don't know that there's going to be anything I can do, and again, I don't know how well it's going to show up on the camera, especially with those bright bar LEDs. The yellow and green rectangular LEDs there are super dim. You can see the red ones at the top there light up. They light up fairly bright, but the yellow and green ones are just dim, and I think it might be that type of LED. I don't even know if you can still get those, or the new sets that they make of these, if they're using something different. So that might very well just be how they are. I'm looking at the code snippet that you can download from the Printed Droid shop for these boards. It does mention that they are set to their highest brightness because they tend to be dimmer, but I didn't expect them to be that dim. I mean, like I said, I've got an overhead light on, but if you're at a convention, you're going to have overhead lights on, so I mean, that looks a whole lot better. But are you going to have dim lighting like that at a convention? I don't know. I mean, I guess it is tucked into a recess also, and the door will open, so that'll be blocking some of the light, but I don't think that's a problem with assembly or code or anything. I think that's just these rectangular LEDs. That's how they are. They're just not that bright. And they are the proper ones. I think they've got 2 different LEDs or 3 in them. You can see how they're half lit up or all lit up. So yeah. So I will be using this now that I fixed it. And the other thing that I want to do, that I might have to download the code on his website and alter the code, is these 3 lights here, and I believe this, which you can see part of its scrolling pattern is red, yellow, and green, is you can use it for a battery meter, where it's got an input in the top. There it goes with the green, yellow, red. It's got input screw terminals in the top that you can hook your battery to. You have to order it with the right resistors. This one does have resistors for 24 volts, which I'm guessing means the code in it is set for 24 volts. And then this should light up red, yellow, green when the battery's fully charged. When it reaches a certain voltage, the green light will turn off, so it's just yellow and red, and then when it drops lower, it'll be just the red. So it gives you an indication that's not perfect, doesn't tell you actual voltages or how long you have left to run the droid, but it does give you an idea of when you have gone through some of your battery. And then this one too, I believe, does the 3 colors, and then they start going out as the battery drains. So what I need to do is, at some point after I've been running the droid, is put a multimeter on the 24 volt bus and see, or I guess not even that, I guess I could just look at this and see what the voltage drops to, and then change the code and re-upload it to the board there that's on the back of this to update the code so that it matches the profile of these batteries. So if these batteries stay at 26 for quite a while and then drop to say 24 and then drop to 22 or something, I'll need to figure out what voltages, because they are in the actual sketch that's programmed on this, the 3 different voltages for the green LED, the yellow LED, and the red LED. So if it sees that voltage, they're all on, and then when the voltage drops, the green one goes out, then the yellow goes out. The other thing I want to do is set it so that it is doing that instead of this random stuff. Personally, I prefer a more traditional look. This also has rainbow, because these are RGB LEDs, they can be any color. This does a kind of a red flashing thing like is like an Empire, where it's just flashing red. That's what I want for that. But it does that, and then it goes into the rainbow color thing, just kind of like this is doing. I want this one to do the battery meter only and not cycle through to the rainbow color stuff. Just personal preference. I just want it to be a battery meter, and I want that to be random red. So I know that that stuff is in the code. So again, I will probably be uploading the different code to that. So just wanted to add this on to the end of the video, because after I stopped that first video and I adjusted that meter and then plugged that in, I was more than a little unhappy that this board that I got from Printedroid in 2021 had a problem with it, with not good soldering. It's got a quality control sticker on them. All this stuff has quality control pass stickers on it, but I guess if maybe that was just enough solder to pass quality control, and then in shipping or whatever, the lack of proper amount of solder on that LED just made it wiggle loose or something. I guess that could happen, but still, it just shouldn't be like that. I shouldn't have had to fix that. But I am happy I fixed it and didn't melt the LED and have to source another LED. But yeah, I think that's all I'm gonna do tonight. The reason why I don't have the battery hooked up to this yet is because it recommends, well, it doesn't recommend, it says you should fuse the voltage from the battery that's coming into this for the battery meter function with 1 amp fuse. So, and it also should come from the battery before any voltage regulator. So I could take it directly off of the 24 volt bus and this ground bus, and that should be fine. But I wanted to put an inline fuse, and I went to auto parts store and wasn't happy with the fuse selection and decided to order from Amazon some blade 1 amp blade fuses, and I think it's like 4 or 5, a package of like 4 or 5 inline fuse holders that hold the blade fuses, the standard size blade fuses. So that way I'm not using like a glass type fuse to fuse this board and these blade fuses to fuse everything else. So in case I'm out somewhere and the battery meter has a problem and the fuse blows, I can have blade fuses on hand to replace them, and if I run out of 1 amp blade fuses, in a pinch I could throw a 5 just to get it up and running again if for some reason I needed to do that. I just rather keep all the same type fuses than have a mixture of mini fuses and standard fuses, or standard fuses and the glass fuses. So that's why I decided to order those parts from Amazon along with the 1 amp fuses. The auto parts store didn't have 1 amp fuses in the blade type, only in glass. So that's kind of why I made that decision. I did buy a glass inline fuse holder, got home, went through my arcade parts, and I have every fuse you can imagine except for a 1 amp fuse. So I could have thrown a 2 amp fuse in that just to get the battery thing tested to see if it does in fact light up, and if that makes that stop doing the rotation between the different color patterns. But I think in the sketch you have to uncomment the battery meter part of it to make it stop doing this and actually act as a battery meter. So again, sorry about that. I took a video that probably should have been a separate video and added it to the end of the other one to make it even longer. But hey, I love my long videos. So there we go. Successful test of the battery system, and successful test, I guess, of the 5 volt rail, and successful repair of one piece of the electronics that I've had for a couple years and haven't tested.